For this video, we have two separate groups. This is how we usually place them if we are going to test for significance between the two different groups. So let's say in this, we have 90 respondents or students, and the first column would be their student number. Okay. Then the second column pertains on a specific assigned group. Let's say we call it 1 for all of these students here until the 45th student is under the first group, and the 46th student until the 90th is labeled as 2. That's for our second group. And for our third column, these are the scores, or specifically, let's say that these are retention scores of the students. Now, let's find out if we could use here the independent samples t-test that will allow us to test whether there's significant difference between the two groups. But that is only if we could establish already the normality between the set of data here. Since we have two groups now, we are going to test both groups in terms of normality. If one or both groups will fail the normality test, then we cannot use the independent samples t-test, but we're going to use a separate form of test, which is the non-parametric test equivalent of independent samples t-test. So going here, before we start with that, of course, we have here our variable view, and we could see here the labels that we used in determining the columns. As mentioned, the first column is for the student number, which corresponds as nominal data, because they are just equivalent to representation of our students in terms of their number. Now, for section here, this now comprises the two groups. Of course, look at here, we have these values here that were determined already, being the first one would be our, let's say, control group, because we are trying to compare two groups, and the second group would be our experimental. So we just simply add value labels here. You could do it like this, let's say for 3, and you add here, say for example, experimental, what you call this one, 2, second group, and when you add that, you will have it added later. But of course, since we have two groups, so let's cancel this, and let's say go back here. So again, for all the students under 1 would be our control group, and for number 2 would be our experimental group, and of course the measurement is for nominal. Now let's try to have this, the third column, which is scores. We'll have here again retention scores, and that would be for the scale measurement. So going back here, these are all the data presented. Now again, before we could test either independent test or its equivalent non-parametric test, which is the Mann-Whitney U-test, let's try to test for the normality. Now, let's have these two hypotheses so that we could be guided later on what to do in our process. Let's have our null hypothesis here, stating that the set of data scores, which corresponds to both groups, is not significantly different from a normal distribution. In other sense, it also means that for this null hypothesis, our set of data scores for both groups are closely similar to our normal distribution. Of course, this is the hypothesis that we are going to test, and if we are to reject this, we'll have this alternative hypothesis stating that the set of data scores, which is for the both groups, is significantly different from a normal distribution. This alternative hypothesis will just come in once we reject our null hypothesis, basing on this region of rejection, where we usually reject null hypothesis if our significance value, or the p-value computed, is less than 0.05 by using a default confidence interval of 95%. So if this will happen, then we are to reject our null hypothesis, and definitely will tell us that the data of scores, or data scores here, specifically the retention scores for both groups, are not normally distributed. Of course, for some of us who really like to use independent t-test, a parametric test for the test for significance for two different groups, we would like the null hypothesis to be retained, or we need to come up with a interpretation that we are failing to reject null hypothesis. But of course, if we are to reject it, means that's less than 0.05, then we'll be using the Mann-Whitney U. So let's try now to test whether the two groups are normally distributed. So this is how we do it. We click here, Analyze. Once you click that, you go to Descriptive Statistics, and once you hover to that, you will have these options here. You go to Explore and click Explore. Again, Analyze, Descriptive Statistics, Explore. Once you click that, you will have this dialog. Okay, so we are to place the retention scores to our dependent list by clicking that and clicking here. Okay, or you could even you click that one here there. For our factor list, let's just simply place section here as the grouping factor. But of course, student, just simply let it that because we have that as our representation only for the student number. After this, you go to your plots and you click this normality plots with test. Once you click that, you can now go to OK. Now, some of the suggestions is you can unclick stem and leaf. You can click histogram, but of course, just for normality test will do, so just simply unclick this one here. You will have probably some other discussions as to that. And now you can click continue. And you can click OK and test later or see the results. But of course, if you would like to click statistics, you will have here the descriptives and the confidence interval 95%. That's the default. And you have your options here. But of course, we're okay with that. You click OK. Once you click that, you will see this result. You will see a lot of tables here, but I would like you to proceed immediately to this third table for the test for normality or test of normality. Now we have two types of tests here. We have the Kolmogorov-Smirnov and the Shapiro-Wilk. Now Kolmogorov-Smirnov are good for large quantities, and let's just focus on Shapiro-Wilk. We have 90 students earlier, or 45 entries per group. Now Shapiro-Wilk can do well for that, since Shapiro-Wilk has suggestions that can be used for less than 50, even less than 100. Less than 200 could also do that. Now we also have a lot of tests here as well, and one of which is the QQ plot. You may have a separate discussion for that, because our focus here is only for this Shapiro-Wilk. Look at the two significance value. For the control, this is the group 1. Okay, this is their test for normality, and for experimental, you have here 0.198. Both of these results are greater than 0.05. Now, looking at our region of rejection a while ago, we can only reject our null hypothesis stating that the set of data scores is not significantly different from the normal distribution if the significant value is less than 0.05. But both of these scores here, we have 0.774 or 0.774 and 0.198 or 0.198. Both of them are greater than 0.05. This means that we fail to reject our null hypothesis, and that we can say that our set of data scores for both groups are just closely similar to a normal distribution. So these are the scores that you would like to focus. So going back to our data earlier, these scores from 1 to 45 comprises the group 1. Okay, we have the 0.774 earlier. Okay, and our second group, 46 student to our 90th student, we have the 0.198. Both of this set of data scores are closely similar to a normal distribution, or it's not significantly different from a normal distribution. With this in mind, we can now proceed to use the independent samples test, because both groups are now closely similar to a normal distribution. And if we're going to proceed for test for significance, we can use this form as well, this type of placing data, as we test for that. See you in the next video.